Okay. So I'll start with some simple concept. So obviously you need a, Linux machine or you need a Linux environment in Windows to run all this. So suppose I'll open a simple program for you. Can you tell me what is this? You understand this program? What it will print? Oh, this is an old program. I have written it when I was in IT Roper. Okay. So it will print welcome to IT Roper or it will not print? It will print welcome to CSE, right? Because of max. You know this? This hash defined max, you know this? Okay. So now how we run a program, I don't know Ashish has covered this part or not. That's why I'm quickly covering this. So this is how we run a program, right? The program name is my program. So program.c minus o and maybe suppose output. So I'm giving my out. So the program is now done, right? So the program is compiler has compiled my program and converted a file called my out. So what is my out? My out is an executable file. So and if I run now with my out, then welcome to CSC, the program you can run, right? So this my out is called ELF file. I have written it. So it is called executable and linkable format. This is a special kind of file, and this is your task. I'll give you this task as an assignment also, that you need to go and explore more about the internal structure of ELF file. At least the basic internal structure. You will understand it more when you'll go to a computer architecture course. So in computer architecture course, when you need to directly write assembly language code, that time you'll understand it even better. But some high level idea of what is the structure of a ELF file, it's required. At least you should know that. So this file, though there is no file format is there, you can write a dot out or you can write it as no, you can write my out or whatever you are writing. It is your name, but this file format is a ELF file format, and this file OS will directly understand. So whenever I am writing this command now, it means that I am trying to run this file, right? So it's an executable file. You can execute it. Who will execute it? Linux kernel. So this file is written in such a way that Linux kernel should understand many important things. The where is the code, where the program should start, where are the global variables. Many things this is written in such a way that kernel should understand. Okay, OS kernel, at least kernel, it's I have explained previously also, right? So the OS kernel should understand that how to run it. And that's why this ELF file is written and it is handshaking with a kernel, and that's how your program is starting. Okay. Now, but there are a lot of internal things happen when you just execute this line, GCC my program. It is not directly happening. There are a lot of internal steps are there. Let us go with these steps one by one. Let us not directly generate my out. So if I go for this, I think program is here. First, let me go with this command. If I go for this command instead of this, let me remove all these things from this. I think only the program is required. Remaining things are not required. Yeah. So now, if I go for this command, cpp my program, and my program, this symbol here in Linux is called output. I explain it later, but it means that this output should be generated in this file. So cpp my program, this command will convert your code to a lengthy code. Why lengthy code? Because if you go to your code, you see, if you go up, you will see there is a line called stdio.h. This is a header file, right? So first, your header file should be included in your project, in your the same file, and this max that you have written, this is for user friendliness only. It is not for compiler. It is for make your program more efficient for a programmer point of view. So max that you have written here, that will be replaced with 50. All these things will be done, and another version will be created. Okay. So the moment I execute this, okay, just 1 minute. My program dot C. So the my program.c is converted to my program.i now. So let me open my program.i. See, the my program.i is created here. So if I open it, now you'll see there's a long program now. You don't need to understand a lot of things. Basically, the upper level things are actually the content of stdio.h. Because of that header file, all these contents are added here. See, there are a lot of other things also. It's you now need to understand all of this thing at this moment. If it is required, you'll understand it in compiler course, not here. It's not possible also to understand. But see, your small program is now converted into a long program, right? So now what part is important for you will be the bottom. See now here, the max is converted to 50, right? So all these things will be done. And now this is a joint program. So it has all the header files and all after linking with, after connecting and with all the header files. And this is the program. So whenever you write GCC, this is the first step. They will create this program. Okay. And then from this program, they will try to convert it to assembly language code. Okay, so next is how to convert it to assembly language code. So there will be, I'll go for the next command. So you can easily see the how many lines were there. Uh, there were only 13 lines in this code, and after converting here, there are more than 800 lines. Okay, so now what next? Next will be if I want to make it assembly language code, then we need to run this one. Now, if I run this GCC minus S, the minus S is for convert it to assembly language and from which my program.i and a minus O means output. Where you need to output it, I need to store it in my program.s. So if I type this and then I go back to the folder,
So
huh?
what dot I say? What the
Dot .s file,
what I
dot .i is the file that just we have generated in the previous step.
what in that all the terms it is a C
It
code.
is a C code. It is a C code on. Okay. So now the next is this .s file. If you open .s file, then you'll see it's an assembly language code. Okay, it's an assembly language code. Again, I hope you'll maybe some of the instruction maybe you'll understand, but not all because this is not RISC-V. This is I think x86 because this laptop is in running in x86 ISA. So the compiler will convert it in x86 only. So this is x86 ISA. Otherwise, this processor will not understand, right? I hope from first week I've explained, right? That processor need to fetch one instruction at a time. So whatever program you are compiling, your compiler should generate the instructions. The ISA should be same as the ISA that this your processor will understand. This laptop is running on x86 processor. This is an x86 processor. So the compiler should convert it into x86 assembly language. So in architecture course, you will learn how to write assembly code in RISC-V. So almost similar kind of program you will write, but not in x86 in RISC-V. Okay. So now this is the assembly language code which a computer understand directly, but still it is in a user readable format, right? It's in assembly code. Assembly code is also for you. It's just for it's written in English, right? It's like English like language. So now you need to convert it to binary. And after converting it to binary, then only after converting it to binary, you'll can generate the executable. So the next step is the last one. Here, now an assembler will be not GCC. Now the next step will be done by an assembler. So that's why I have written AS means assembler. And you need to give the output as my program.s, which is the assembly language code. Then you need to give where you need to output it. So here it is written out.o. At this moment, if you want to go for more linking with other objects and all that also you need to do before creating the final output. Okay. That part I think Saurav has covered, right? If you have a make file, then there will be multiple how to connect them and all. But basically, if you need to perform a linking and all, then in this step, the linking will be done. But let us not discuss here. But after this, if I execute, run this, then out.o is created and that out.e is your ELF file. Now you can run it. Sorry. Cannot execute binary file. Execute file. There may be some issue. It should. It should execute. I'm not sure why it is not executing. My out cannot execute file execute.
What is the difference between my program dot SDF count?
Just 1 minute. Let me try why it is not. It should execute. There may be some issue. Cannot execute binary file format. Is it like this?
You must have noticed that it was not running during the lecture time. So what mistake I have done that time is I was just trying to run a ELF file which is not an executable file. To make it executable, you need one more step which is called linking. So what I have done, it's not. It was just before the linking. So you just need to write this above command that I have written here. You just go for GCC and minus O, then this current my out, and then you write minus sorry GCC my out minus O, and then give a new name here, and then try to run execute that one in the next line. Then easily it will run.
There may be some issue. I'm not sure. Let's not spend time on it. But yes, this is how it will execute. I'll check why it is not executing. I'll show you another file. This is how it is. I have tried it also. Huh?
CPP means it is not
Huh?
CPP micro. So what is the
Okay. The CPP is a command. It is whenever you are giving GCC command, inside GCC command, it's actually divided into multiple parts. First, it will go for CPP. It's a package. Whenever you are saying GCC, it's a package actually. It will first convert it to the myprogram.i file. Okay, it will convert all the standard libraries into single file. It will merge all, it will convert all your symbols and all, and then CPP is done. Then next step will be converting your code to assembly language code. That will be done by AS command. Okay. And then after that, once your assembly language code is done, then from assembly language code, the object file will be created. So who was asking the difference between, yeah. So .s file is the assembly language file. It's not the machine language file, right? So you need to convert it to machine language, and then also you need to make it executable. Machine language file is not and also not just an executable file. Converting it to machine language, and then you need to create a final executable file that is called ELF file. So for that, you need to go for the last command here. But I don't know why it is not running. It should run, but I'll cross check it why it is not running. It should run. Okay, maybe next class I'll tell you. But I hope you are getting a high level idea. But no, normally what we do, we just run this code, right? Uh, this one. Sorry, we just run this one. GCC. This is what we need to do. GCC my program dot c minus o and the output file, and you will get the ELF file. But internally, a lot of things happen. And just trying to explain it to you. But please know that you no need to understand the syntax of assembly language. It is not required for now. You just need to understand the steps. That's it. You no need to understand what is happening for this what is happening inside CPP and how it is converting. All these things are not required at this moment. There are many high level codes here. Some of this concept will be cleared in OS, some of them will be cleared in compiler, some of them will be covered in architecture. And as I said at the beginning of this course cannot make you expert in anything. It's not possible, but it will give you a high level idea of all of these things such that whenever you will go and whenever you will take that particular course, it will be easy for you. You will understand the high level concept. So this course will give you a high level idea of OS, architecture, as well as compiler. Okay, this is fine. Now let's move to some other concept. This was discussed by Ashish or not? This whatever I have discussed now, it is not discussed, right? Okay. Then process. Okay, so now the one more thing that I was discussing last week also is called process, right? So whenever this my out is fine, so my out is a ELF file or executable file. Well, whenever you are writing this one, here dot my out, then your program is running, right? So if the program is running, immediately whenever you are giving this command here, this command and pressing enter here, you are instructing Linux kernel that okay, run this executable. The moment the executable will run, then it will create a process. Okay, and every process, whatever you are running, a process is there for it. So that's the concept. So from process will be generated from the ELF file. First, there will be ELF file stored. It's a file. It is stored. It is not. It's the executable file, but it is stored in your hard disk. You need to instruct the kernel that okay, run this executable. Then the moment it will run, a process will be generated for it. I'll show you the based on some other program. So I have written. I have another file here. In this file, I think I have a program called simple PID. Okay. Let me first. You don't need to understand the concept first, the syntax first. Just you need to see this. There is a printf command here, right? And there is the unconditional while loop. So if I run this program, some printf will be coming continuously, right? So that is enough. So let me compile this program and run it. So GCC program name is simple PID dot C minus O, then suppose out PID. Okay, now if I run it, see the process. This basically you no need to understand what it is printing, but one printout is print statement is continuously printing. Why? Because of a infinite for loop, right? So now what is happening? You just if you see this command here, GCC command, we have created an executable file called out PID, and here we have instructed kernel to run this program. The moment it run this program, it has created a process. I'll show you which process. Okay. So now from here, if I write PS minus AF, it will show me all the process currently running. PS minus AF. So now you can see the process that it has created is this one, 3623. This is the process ID. Why I am saying this one? Because you can see the name here, the command, through which command it has created. This is the command through which this process is created. It's correct, right? Out PID was the command through which we have started this process. So this process, every time how many process this system is running, you can get it if you type PS command. AF is just a argument based. You can do many other things with PS command also. So you need to explore PS more in more detail. But yeah, PS is a command in Linux. It's a Linux command. If you throw that, you can find out how many processes are running. If I just write PS, then it will just give you this small short description. It will not give you the long description. But I need a bigger description. That's why I'm going for PS minus F. Okay. So now the concentrate on this. This is the user ID. Who is the user of this process? Which is the process here? This 3623 is the process which is here currently running. And you see one more process. See that what is 385? 385 is the terminal process from which I have started this program. Right? The terminal is also a process. Right? This is called terminal. This is also a process. There are many other processes which is not showing here. The kernel and all process. Some processes are not. All are not showing here. But the process which are directly started by this user, it is showing here. Okay. And then there are some other information also that I will come after some time. But see the command which has created this process. And this process is running. Now, if I write here kill 3623, then this program will stop here. This program is still running. If I go down and see, this program is still running. Okay. But you can either stop it from pressing Ctrl C here, right? If I press Ctrl C, the program will stop. But let us not stop it from here. If I write kill command here, then also it will stop. This is also a command. And this concept is called signal. I'll come to signal later. So it means that, see, this terminal is a different terminal, right? This is a separate process. Means from one process, you can close another process also. How? Because from one process, you can instruct kernel that, okay, I want to kill this particular process. You can give a kill command to kernel, and kernel on behalf of you can close that process. So you throw that window, you can close this process. So the process is stopped now. Okay. So now the main idea here is to explain you that every time. So let me run it again. I'm running it again. Every time you try to execute a program, a process will be created. And now see the number is different now. Previously, the same command when you were given, the process ID was 3623. Now the process ID is 3635. The process ID will be dynamically generated. Every time you run it, a new process will be generated. Now, one interesting thing is if you run it again, suppose I'm not stopping it here. Okay. Let me not stop it here and go for one more. I'm going to another window. This is a separate window or yeah. So from this window, if you can run another command also for this, that's I'm trying to. Ls, sorry, ls. Okay. Then what was the file? PID, right? Or out PID. See, so what I have done, I'll show you two window here. One window is this. Here also I have run the same. So there is only single file is there, right? Basically, if you go to this folder, you'll see this out PID is a single executable file. But I have executed it twice. Same time, I have executed it twice. See how from this terminal, I have executed it here. And now a process is generated. Process ID is 3635 and it is running here non-stop because of infinite while loop. Now go to the another terminal. This terminal also I have went to the same folder and I have run it. And now it is running as 3650. So here it is 3635 and here it is 3650. So what you understood? Every time you try to execute a ELF file, a process will be generated. It's not if you have, it's not necessarily that single time. If you try to execute the same thing multiple time, every time there will be a separate process. And these two process, there are two processes, right? One is 3650 and another one is 3635. There are two process. These two process are running in two separate core because this laptop has 8 core. This laptop has 8 core or I think 12 core. So this laptop has 12 core. So two processes can run in two independent cores. This is a very simple, small program, but it's a dangerous program. Why dangerous? Because infinite loop is there and it is consuming more resources. So maybe OS, the kernel will assign first process to one and another process to another core. Let me check it from here. I hope this information will be here. If I go for more detail, yes, I think this one is the core number. So this, you see, the 3635 is running at core number 7 and 3650 is running at core number 9. Okay, that's the benefit of multi-core machines also. That if you have multiple programs, multiple things, then it will run in multiple places. The basics of process is clear. One more thing which is very important is to understand the structure of a process. Whenever a process will create, you will see all the process details here. CD, I think slash PRC process. If you go here in this folder, you will see all the process details here. So this is a folder you can write here. You can go CD process. This process folder is a folder where all the process detail will be there, which process are currently active. Okay. So you'll find these two process also 3635 also you will get. So if you now go for more detail and if you want to display about 3635, go for 3635. Okay. Now if you go for ls, then this all details that you can see ls minus l. I'll go for ls. You know ls. Ls is just to display what are the content in that particular folder. If you don't know, then I will gradually understand all this command. But now I am using ls, so just note it down that ls. ls is also a Linux command. If you don't know it, because this course is not for teaching Linux command, but we will use Linux command. So by using Linux command, you will understand most of the common Linux commands. So if you are not getting it properly, ls, just note it down. Ls means like same thing that I am displaying here. If what I'll do, if I click on this process folder, what will happen? You can see all the content of this folder, right? Same thing ls is doing there. It is going inside to that folder, and you give ls command, then it will show all the files available in this folder. Okay. So now it first what I have done, I have went to this process folder. This process is a folder here. And then once you give ls, then it will give all the details. If you go for ls minus l, the same details will be given in a more detailed way. For each file, there will be a row here. So there are many internal details are there for each process. But you no need to understand all of them. It is not possible. Even I don't think in OS course also the people means you will understand all the internal structure, but it is as per your interest. If you want to explore more about it, just spend some time on ChatGPT. In our time, we need to spend time on Google or some books. You don't need to do anything. Life is very easy nowadays. You just explain that I want to know the internal structure of a process, or just you tell ChatGPT that suppose I am in this folder, proc, and assume that inside proc there is a process called this number. Just ask ChatGPT and say that explain me the internal structure. Then automatically will explain all the details to you. All the details are not necessary for you to understand, but some details are required. So for before that, what I have not explained so far is I said that a process will be created. Whenever a process is creating, at the same time, some multiple things are happening. The main thing is it is creating an address space for you. If it is a process, then at the beginning I said that everything has an address, right? CPU will request for an instruction. How? Based on an address. CPU will send an address that I need that this address. Every instruction or data, it is an address, right? Because the purpose of program counter is, you remember program counter, right? In program counter, we are storing an address. It means that next time you need to go to this address and fetch an instruction. What is that address? This is not an address of your secondary memory or something. This is the address of your virtual memory. And that virtual memory will be created when a object process will be created. Whenever a process will be created, a memory will be assigned, and that memory is called your virtual memory. And address suppose from 0 to 1, that address will be there. So now in that virtual memory, some part maybe it will store the code. This part will store the code or the instructions that I said, right? Instructions 1, instruction 2, instruction 3. This instruction will be stored here. Okay. And other parts will also store other details. Suppose here one part is called heap. Heap will be there. Then one part is called stack. All this entire virtual memory will be divided into multiple parts. Okay. And these are for different purpose. So the first part here is to store the code. So that the thing that we say the program counter is storing address. Program counter will store the address of this, maybe for these and then these. This is how the entire code is here. It may not necessary to start from 0. This is just an example for understanding you have written. But the entire address case, some address will be some such a segment will be given to code, and the program counter is requesting for these particular addresses. And your data will be also here somewhere. Okay, and based on that is executing. So this is called your virtual memory. So whatever address that I said at my first week, that address that everything in the memory either is an instruction or data. Data also, if you remember, I used the example a plus b plus c. I said all of them are in memory. If you remember my example, a, b, c, I have used 3 variables. I said these variables are also in memory, right? This variable will be stored here in this location. If you are using dynamic memory location that you use, right, malloc, you use malloc, right? If you are using malloc to reserve a memory, that will be stored here. Okay, but it is inside that process only, and you can access this location. Some location you as a user you cannot access also. From entire address space, there will be some location you as a user you directly cannot access. Only kernel can access. So this is the high level idea of a virtual memory, and that's how it is organized. This memory is not necessary that it is fitting in your main memory. This is also a very interesting concept. I may not cover everything that I was planning today, but I hope you are finding it interesting, right? Do you know all these things, or it is first time you are? If you are listening it first time, then this is a very important concept, and people will ask you even 10 years after also if you are going for an interview. These are the most basic concept of computer science. It's called virtual memory. Whatever subject you are expert, I mean, after 4 years, if you say I'm an expert in machine learning or whatever it is, if you want say that I want to work, I know systems, computer systems, then people will ask you. Okay. So now in class, I said this thing, right? That initially there is a cache memory, then there is a main memory, then secondary memory. But the main thing is main memory. So this virtual address is maybe bigger than the main memory also. Suppose this one process you are running, it's a very big process, and entire this size is suppose 32 GB. This is 32 GB. But your RAM is just of 16 GB. Can you run it? Still you can run this process. Why? Because this 16 GB is not enough to store 32 GB fine, but some of them will be stored in secondary memory. Have you ever installed OS in your machine? If not, then try it once. It is also important. If you try to install Ubuntu in your machine, it will ask you swap space. It will ask you for a swap space, how much, or maybe just at least try to see a YouTube video how to install. Then at least if you check a video also you'll understand that it will ask you for a swap space. Swap space is for this type of thing. Okay, if you have a secondary memory and it's full with your other content, like you have stored video files and all, and the STD is full, then you cannot run this type of thing. That's why what happens whenever you're installing a OS, that time only it will say that from your you have a 1 terabyte of SSD. From this, how much you want to save as a swap space. If you say that no, out of that I want to save 50 GB as swap space, then 50 GB will be separated. That 50 GB out of 1 terabyte you cannot use to store your normal data. You cannot store it because that will be used when program will the computer will execute. Why? Because whenever you want to execute a program, at that time a process will be generated, and if the program is bigger, then based on all these details will be there in your ELF file. These details will be there in your ELF file, that what should be the size of this virtual memory. This is not same for each process. These details will be there in ELF file, and if the size is very large, then and your memory is just 16 GB, memory means main memory, then the remaining things it will take from the swap space of the hard disk. And most important information will be here. Whatever is least important, it will be written back in the secondary memory, and most important will be here in main memory. This is how it will manage. Okay. That's the main concept of virtual memory. So normally people don't understand it in that way. People say that okay, main memory is not big enough. That's why we need a virtual memory. And this are all not correct information. Correct information is that every process is a virtual memory. And if it is not fitting, and then some of them will be there in swap, but most important will be fetch here and we'll do it. We'll perform the execution here. But if your process, suppose if you are, do you know about memory leak? This concept was discussed in your C programming. Suppose you go for a dynamic memory allocation, you need to free it also. If you are not freeing it, it may consume more memory. And after some time, maybe it will also consume your swap space. If the process size is, you have given some option, something like that, okay, memory is increasing or doing something, then what will happen? If it is increasing and it is crossing the swap space, then it will crash your system. Okay. One more interesting point. Now, assume that you have suppose you have two code and same mesh program you are running, the same thing that I said here. If you go that I have shown you, right, the same program is running in two code. The same, assume that the same program that as I have shown here, 6035 and 6050, these two program, one is running here and one is running here. These also need a virtual memory of 32 GB. These also need a virtual memory of 32 GB. It has only 16 GB of RAM. Do you think it will run? Do you think it will run? Yes, it will. Otherwise, many systems will crash, right? Because it will definitely run. Why? Because this 16 GB now will be divided into 8 GB, 8 GB. And the remaining things will be there in swap. But the swap space 50 GB that you have stored, that should be enough to include these two stories. One, this, and there is one more process, right? Whatever information required for these two, that much space should be there in swap. Your swap should not be filled. If you have enough space in swap memory, then Even with 16 GB of main memory, even less than that also, even if there is only 8 GB of RAM, you can run it. Maybe it will slow, but it will not say that no, I cannot run it, I don't have space. Did you see any this type of things that okay, the RAM is not enough, there is less size? So normally, oh, this kind of information you will not see. You will see it only when your swap memory is full. Okay. So now this small memory will be divided into these two. Same thing like replacement policy will be there. And then if this most important files or pages will be there, the remaining thing will be in swap memory. What is page here? You know about block, right? I explained you cache block. So whenever there is a miss in cache, you need to go to main memory and fetch a cache block, bigger size because of spatial locality. If there is a miss in main memory, you go to lower level, that time we fetch a page. It is even bigger. So if whenever there is a communication between main memory to secondary memory, that is called page. And there is a main memory to cache, that is called block. Block I have introduced in class. I don't think I have explained page. So this is called page. So now that's why even you need a two bigger size processes there. Then also you can execute it because of virtual memory, because this one has its own virtual memory and this one has its own virtual memory. These virtual memories are separate. Some of the time that they are using this common memory, but it means not like that they are using the same addresses. Addresses are different, right? It's like that. Here there may be this same class is there, but BTech first year and BTech second year, two courses are running here. No students are common, right? But they can use the same space like this. This ECV is using by this address space as well as this address space. But doesn't mean that one can write on each other's location. But if based on the requirement, this 8 GB will be divided. It's not like 4 GB, 4 GB. OS will decide how much should be given to each one based on the requirement and all. Okay. That's why as a programmer, whenever you are writing a program, you no need to think about what is the RAM size. When I will run this program in a multi-core machine, is there, it will run alone or it will run with some other application? Do you need to think all these details whenever you are writing a program? No, because of this. Because whatever software or whatever program you are writing, whenever I will try to execute in a machine, it will create a process, and that process will have its own virtual memory, virtual address space, and that address space is unique for all, right? This one and the second virtual address, these are two separate things. Okay. And you no need to think about the main memory space, because this whatever main memory space will be there, that main memory space will be shared among all of them. And the extra one will be there in the secondary memory as a swap memory. And that is the concept of virtual memory. Okay, so that's why sometimes people say that one more question is, suppose you have a 1 TB of main memory. All these things I say that main memory is very small. Virtual memory concept is clear, right? I will now ask you another interesting question. Virtual memory concept is clear. Swap memory is clear. Now suppose you have a 1 TB of main memory. Enough main memory is there. Not even 1 TB. I think I'll say nowadays, yeah, even 1 TB main memory is common for modern processor, modern server machines. Even our server machines that running in our IT Hyderabad data center may have 1 TB of main memory. Not practical for your laptop, but practical for server. If we have a 1 TB of main memory here, these two virtual machine will virtual memory will directly feed in the main memory. Even after that, there may be free space. Do you think virtual memory is required? At that case, if your main memory is enough, means whatever program you are running, your main memory space is enough. You no need to go for a swap space. At that time, do you think virtual memory is required or not required? Any purpose coming in your mind that no, that time also it is required? That time also it is required. Why it is required? Because this address is local to each machine. Each process has its own address. So this address and this address are relative one. Here also you can find a 500 address. Here also you can find the same address, because these two are relative thing. And whenever these address are coming here, this main memory, there will be two 500 here. One from here and one from here. You need to separate them. If you are not separate, the same address will be read by both the process. This is not correct, because this is the address space of one process. This is the address space of another process. Here may be address 500 may be there. Here may be also there the same address, because whenever you are generating this address page, it is not aware how what other process is, right? So it means that if you are not taking care of process, then maybe what will happen, there will be two 500. So that's why there should be two separate address files. This 500 is for this virtual machine. So this virtual memory, this 500 is for that virtual memory. That should be separated. So either one process should not incorrectly interact with the other process. So that's why in multi-core system, not even multi-core, in a single core system also, if you want to run two processes simultaneously, then you need the concept of virtual memory. Even if your main memory is larger. This concept is very high level concept, but you need to learn more about virtual memory. I'll quickly show you where the virtual memory is. So now in this concept that I have explained, in the all the details are there for each process. Suppose this process 3635 is running, and if you want to know more about how much memory it is taking, then you can go for its memory details. I think this command I have already stored here. For that, you need to write this command. Cat. And what is the process ID? Process ID is 3635, I think, right? What are the 3635. 3635. See, so if you run this command, cat is a command just to cat is a simple Linux command. It has no connection with process. Cat is to display file content. Instead of cat, if you can write a C program also to read this file. This is a file called maps. Inside the proc folder, there is a inside proc folder there will be one folder for each process. So this process 3635 is currently running, so it has a folder there. Inside 3635 there are multiple files, and those files are displaying above. See, all these files are displaying above. One of them is called maps. So if you want to read that map file, either you can read in any other way also. Cat is a command. And if you click cat and this file, then it will display here. Not just for this, if you have a file like myfile.c, if you write cat myfile.c, then your C program will display here. So just write down the cat. You need to remember what is cat, but it's not related with this process at all. It is just to displaying the content. But if you display content, then these all are the address spaces that I am showing here. If you see the first line it is showing the address. This code, these four, see, all these are actually for the code, the assembly language code. Now you can relate with this with my first week slide. In first week slide, there is a program where I have shown in memory one part assembly language code was there, and another part I have shown the A, B, C, D variables were there, right? So this part is called the source part. Your source will be stored in this memory location. Source is also divided into multiple parts. Some of this part you need this X permission is that this is actually the actual code of it that you can execute because X permission is there. Others are not for executing. I am not explaining it in more detail, but this also I'll give you as an assignment that you need to understand the structure of this file, map file. So, but a high level thing is these are the content where you are storing the code. This thing that I said, this code part is there in this all this memory address range. There are multiple address range are there from this to this, and then from this to this like this. And this is your heap. You can see there is a content for heap. So this memory range from this to this is for your heap. Means if you in your program if there is any dynamic memory allocator, if you are using malloc or calloc, then it will save here. Okay, and there is a W permission also. See RW, you can read and write both as a user, because if you use malloc, you can write something also in this memory, right? It's not that, so that's why you have write permission also for that. And this is your heap. After heap, these are for other libraries and all. They're not so important, but this stack is important for it. Stack is for all the local variables. All the local variables and variable that you are hard coding, those will be stored in stack. And the remaining two, I'm also not sure. You can check. Basic, I'll give you an assignment where you need to understand all the structure. So this code is also divided into multiple parts. Out of that, the main code is in this line where the X permission is there. X is for executing. The remaining are read only the part, and the heap is the most important part. Whenever you are using dynamic memory allocation, your memory will be stored in heap. heap is the most important, and stack is also for storing other variables. So this is the high level idea of a process. So let me stop the recording now. I hope it is still recording.